There we go. Okay, let me record. Okay, excellent. We'll go here. So does everybody still have their link? As in the link to the class right there? Okay.
Sir,
No, sir.
PD.
Yeah, because if you do, you'd know that I edited it this morning. There we go. Okay, so we're gonna go through the paper right now. Let's go here. Let's small this up. Okay, excellent. So the reason why I like to really go through papers, and I'm not sure if it's for everybody, it really makes it that we're on the same page. For example, I know persons might have gotten 100%, but I want to make sure that I give credit where credit is due. If someone did something great, I think they should be commended for it. So I took pieces from each person that did the exam, and I'm going to explain now each question. All right? Let's go back here. There we go. Okay. Now here's the first question. Okay. So pull up the exam paper alongside with me. So we can just go through it side by side. All right. All right. Let me just pull it up for you. All right. There we go. Excellent. Let me just go for it quickly. Technical drawing, senior 3. There we go. Okay, so we're gonna look at the question and then now show the answer, talk about the steps, right? And now we know where we need to improve on. Okay, so I took this question from Isaac's answer. Let's look at the first question that he attempted. Scroll down. Okay, here we go. All right. My laptop is still in 2020, my bad. Okay. All right, here we go. So here's the first question. Construction of an engine part. By showing all arcs of construction and line types, detail the construction of this engine part. Excellent. So let me go to a new page and let's show what Isaac did. Here we go. Okay, so Isaac, I'm gonna call on you now. All right, we know how you got these two circles, right? It's a, let me zoom in, diameter of 38 and a diameter of 20, all right? But explain how you got these two small arcs right here, radius of 32.
I think I did some subtraction or something.
Right.
I don't quite remember.
Right.
Try to refresh myself.
So let me explain what he did. Remember, an arc is just a line. Similar to this, let's go back here. Let me go back up here. An arc, like this one right here, is simply an extended line. So if you're at a distance of r, and you need to find a total distance of this arc, you would use r minus small r. Does that make sense? Let me explain. I am at a distance here, okay? And I want to find half of this large R. I would just simply go in. So I would subtract small r from the larger one, and that would give me this point here. Does that make sense, everybody? So it's the same process as it relates to how we got these. So I want to ask a question. I'm gonna label diameter 38 as large R. Let me go here. Let's go here. I'm gonna label now. So diameter drawing, diameter 38 is going to be, let's go, is equal to large R all right, diameter 38 is equal to large R, and diameter 20 is equal to now small r. Let's look at the drawing. So how would we get the distance for this point here? Anybody knows? In other words, what two values subtract to give you 32? Let's look at it. So x minus x gives us 32. Let's look at it. The total distance is 89, is that correct?
That's between the two centers of the circle, yes.
Right. So you would want to use you want to use one of the centers as your point to get the arc right here. Right? So you would say 89 minus something will give us the point here. Right? But I want to ask, what value do you subtract from 89? So 89 subtract something gives us 32. So we can use math right here, right? Transpose the 89 for me, what do you get? Hello? X is equal to 32 minus 89. Well, negative x. Let me explain again. I know that the radius here will be 32, and I'm going to try to draw the arc from this center point. But if I know that the total distance is 89, I need to reduce it and stop here. So I would subtract something else. So the equation is 89 minus x is equal to 32. Does everybody understand? I think I'm glitching because this doesn't sound like my students. Can everybody hear me?
Yes, sir.
Okay, but what I said makes sense, right? I'm driving along a journey and it's 89 millimeters or 89 miles, but I want to stop at 32 miles. Wouldn't I need to subtract and just go here? Does that make sense?
Yes, sir, I understand.
All right, good. So let's do it. So we're gonna say now, 32 minus 89 gives us, it's not a trick question. Let me calculate it for you. 32 minus 89 gives us negative 57 or 57 for x. X is equal to 57. So a method that you could do is open your arc from here at a distance of 57 and you will get this arc right here. Does that make sense, everybody?
Yes, sir.
Yes, sir.
That's for the first one. Let's do for the second one. But there's multiple different ways you could do this. That's why I always ensure that I give you one method and then I implore you to practice using different ones. So we're at the larger circle now, okay? And we want to find this arc right here, okay? So we're gonna say 89 again, 89 again, so 89, right? But this time is not the fact that we are moving further away, is that we're actually closer to it. Because before we were at 89 and want to go back, but now we're just directly going here. So we could find out how much we reduced, which was 57. So the previous answer was 57, right? So it would give you the same arcs. But what I want you to know is not one way you could do these questions, multiple different ways. It's either you use the same formula of R minus R, or you just use the centers, right, and subtract them and you'll find the same answer. All right? Okay. All right. Let me show you now another one that I think students really didn't per se understand is the enlargement one. All right. So I'm going to go over the steps for this one because I think this one is the one that we need to go over more. So let's go back to that class session. So go back here. I'm going to clear up anything that you might not understand. All right? Firstly, what was the first step in the question? Let's go back to the question. The question says, the drawing shows a number 1, which is to be fitted on the door of a house. Enlarge the drawing so that all the measurements have been increased by the ratio of 5 to 2. Okay? Enlarge it. So let's look at it now. So I'm going to search for the page, radial line method B. Hold on, radial. Hold on 1 second. Let's go to the next page. Okay, so I'm gonna go over the steps, and if at any point you're not sure of what I'm doing, just let me. Okay, let's let it load up. All right, there we go. Excellent. Right? Because it's a lot of persons that is in the class, 30. I think that's a world record. Right? I'm gonna just wait a moment for it to load up. Okay. All right. It's loading up. All right, there we go. Radial. Let's go to the pages. There we go. So bear with me for a second, guys. There's a lot of persons that's in the call, so it's slowing it down. What I'm thinking to do, I'm thinking to just pre-record the last 2 questions, which is the octagon and the plane figure of equal area, just to make sure I go through the steps of every question. But I want to hit this question, which is the enlargement one today. Let me go back to the timetable. Here we go. 3. Okay, good. Okay, here we go. Perfect. Can everybody see this document?
Yes, sir.
All right, let's go through it together. Okay, so the first step that I told you was that locate a point P at any distance away from the 1. So you would have drawn the 1 again, you'd have drawn the 1, and then at any point over here, call your point P. All right? And then now simply, after you connect your point P, right? Divide the distance of P to the original drawing into the required amount. So if the question from P to the base right here, right? How much did the question say? Let's look at the question. Go back here. The question said 5 to 2. So in other words, what would be the distance of the original drawing to the P? Okay? If we have a region of 11 to 5 here, then that means it starts at 11. But if we have a region of 5 to 2, that means our original one starts at 5. Does everybody see that? So the one that we want, it starts at 5. Can everybody see that? Let me try to zoom in for you. Okay, so we have P, and we divide a line called B, we didn't have to label it, into 5 parts. 1, 2, 3, 4, 5. And you could have enlarged it or reduce it. So if you was enlarging it, it would have been 5 to 2. So the new drawing would have been at 0.5. If you are reducing it 2 to 5, you would have started at 2 and you would reduce it to 5. Sorry, you're starting at 5 and you reduce it to 2. So it's the same thing, really. Does everybody understand that?
Yes, sir.
Okay. So what I'm gonna do now, I'm just gonna go over the steps, because remember I gave you this in notes. Just in case you don't have the notes, I'm going to just go over it right now. Okay. Let me just check the chat. Sure, Brandon, sure. Okay, let's go to it now. So the second step, from B, continue the equal division, right? Until you meet the base. We done that. Project AB to K. Let's look at that. So when it says project, it means you have two options. Either you do radial line method A and radial line method B. Now, I gave you the option to choose anyone, but I'm gonna ask now two persons. Harshita is gonna tell me the difference, well, tell me what radial line method A is, and Ariane is gonna tell me the definition of radial line method B, okay? Harshita, what do we do in radial line method A that is different to the radial line method B?
Wait, so which one am I doing?
So you're doing the first one, radial line method A.
Oh, not B?
Yeah, so just explaining me, what do you do with radial line method A that is different to B?
Well, for A,
Mm-hmm.
isn't it just a simpler version to B because you have to draw less lines and you start at like a point, like then you connect the lines to each of the points on the shape,
Mm-hmm. Like this one?
extend them,
Right,
and you would create another line going down and then connecting to the same points if you want to enlarge it.
exactly. Right? So that's method A. Right? Now for Ariane, tell me now, what do you use in method B that makes it so different? Ariane, are you there?
Yes, sir.
Right? Now tell me, what do we use in method B that's so different? Let me put the two drawings together. We have method B here, and then we have method A here.
Sir, could you put back method B, please?
Right. So look at method B right here. Right? And then this is method A. What is the difference between those two?
Well, in method B, there were some small circles.
Right. We call those arcs. You can call them arcs. All right. So the difference between, so both of you are correct, because the difference between method A is that it's a simpler version where you just draw lines to connect and then use vertical lines to meet those points, right? Depending on the ratio. And then method B, you just use arcs to find those points on the new version. So it's very similar, but version B, method B, is the harder one. So that's why I saw multiple persons just use method A. All right, so let me go through the steps for method B. After you, because remember, it's the same type of process, it's just a different drawing, but in this case, I'm gonna use the original one. So after you projected AB downwards, so this is AB, you draw a line downwards to find K, right? That's gonna be what you call your reference line. So let me draw on it again. So I did this last year, if anybody could remember. All right, let me just draw on it. I'm gonna use, there we go, pink color, excellent. Let's zoom in back again. Right, so when I draw down, oh boy, okay, there we go. So when I draw down now and form my point K, I'm gonna use some arcs from a point here to find where exactly I need to make it, to make this enlarged version. So step 4 says, from P, draw radial lines through all points on the figure, including centers and circles of lines and circles, sorry, centers and lines. So what you're gonna do, simple as this. Oh, I probably zoomed in too much, my bad, but let me just scroll down still. All right, hold on, let me zoom out. All right, there we go. So what you're gonna do, this point B is your reference, and you're going to just use your compass, swipe an arc, and meet it at point B. Same thing for all other vertex, which is just any point where two lines or two circles meet. So in the case of this one right here, you draw a vertical line downward, right? And then now form that semicircle from this point B to meet this point on the line BK, not Burger King, BK the line. All right, let's do one more. We have the point E right here. We draw the point from B, go downwards and to form a radial line. Okay? Now, let me just do the three examples here. So after you get those curved points, if you are doing the radial line method B for one, you would do the same process. Draw the vertical line downwards, and at every point where you see a vertex where two lines are meeting, you draw a radial line. It's the same process. So the difference now is that using the point P, draw a line to meet and make it pass through every single point, right? Every single point. All right, and you're gonna continue that. But remember, what did I say before? Depending on your ratio. So if you're doing 5 to 2, that means this was 2, and you're gonna stop at 5. So you wouldn't draw your, or you continue yours to 6. You would stop at 5. This would be where you stop, right? And now, whatever that is, you take this point, draw a vertical line down to intercept it, right? Using this point B, you do the reverse of what you did earlier. You actually continue the arc upwards, not downwards, right? And that will tell you now the first point on your new enlarged figure. Does that make sense, everybody? Does that make sense?
Sir, where did you get the radius for the arc again?
Okay, so you take the radius of the arc from every distance where there's a line. So for example, B and C is a line, that's your first radius. Right? Next,
Okay.
right? D and E is a line. So D is gonna be one line right there. And D is another line, E is another line. That's another radius. So this is why it's important, guys, to label your drawings. So on your number one, you would have labeled A right here. So A would be right here. B would be right here. C would be right there. E would be somewhere along this point right here, but you know that it would just be a curve, and the curves meet at one point right somewhere here. Okay? E, F, G, H, I, J, K. So you label every point, and then that's the process, okay? I do have a video up, so if you miss anything, I'm gonna send you the link to that video that you can revise over in a previous class. But that's it for this section. The final thing I want to talk about is just pretty much just covering this, okay? So we know how to get these polygons, but I want one person now to explain the process of getting the plane figure of equal area with a square and rectangle. I'm gonna call on Isaac. Are you there? Since it's your drawing, I want you to explain now the steps to get the plane figure of equal area.
Okay.
Yeah?
So like um, we had, I think it was, we were to draw the rectangle first, and then like we draw a square of equal area. So when you have your rectangle, you extend the baseline to a point, let's call X, like we have in on the diagram right now. And then with the radius of C to D, using a compass, you draw an arc down onto the line, to the extended line part area, and you label the point where the arc touches the line E.
Mm-hmm.
and you find you by you divide the line into two. So B to E, you divide that into two perpendicular bisector. You draw a perpendicular bisector in the middle of the BE line.
Right.
And with that, you put your compass point on the 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 point where the perpendicular bisector meets BE, call it F. And using the radius F to E, you draw an arc from E to B,
Mm-hmm. Semicircle.
and yeah, semicircle.
Mm-hmm.
And where uh, you extend a line CD up to the point where it's gonna meet the arc and call it G. And G to J has to be perpendicular to um yeah, perpendicular to the top of the rectangle.
Okay. Right. So you would.
And
Mm-hmm.
with the length of C to G, you mark off mark off areas where what's it called, the square, like points, the vertex, where you connect the lines. So like you use a compass C to G, and then from there you put the compass point on with the I'm done. I can't.
Let me help you. Let me help you. Okay. So I'm gonna now give you two sentences to summarize everything that Isaac was trying to say. So write this for me quickly, and that's gonna be it for this topic, really. So write a sentence for me. When trying to find the length of one side equal in area, when trying to find the length of one side equal in area, or in other words, to draw a square equal in area to a given rectangle, right? Everybody have that? To draw a square equal in area to a given rectangle, comma, use C as center, use C as center, and radius CD, and draw an arc that meets on the line X, right? And call that point E. But it's just simple. So you're just gonna draw a quadrant of a circle right there, right? Last sentence, bisect B to E. So this entire distance, bisect it, right? And draw a semicircle, as Isaac said. And then finally, draw CD to G on the semicircle. So extend this line CD to meet the point on the semicircle. And that's one section to complete the required square. And that's one section to complete the required square. And since a square, so I'm not telling you to write this now, since a square has the same side on every, you can just, after you find one length, you just replicate that, that's the entire square. Does that make sense, everybody? Everybody understands?
Sir.
All right. Now, I promised a couple students last term that if they manage to complete this topic before the end of the year, we would move on to isometric and all those things that you did earlier. Anybody remember that? I think the persons are here. I won't name them, but they've been begging me to go on to those topics for them. Anybody remember that? Isometric, drawing, and all those things.
Yes, sir.
Right, good. So I'm gonna give you some introduction to isometric drawing again, just to make sure that I keep my promise. Because I said I was gonna do it, so I'm gonna do it. All right, let's go here. Okay. Okay. Let's give you some idea as it relates to getting isometric drawings. Okay. All right. So let's look at this for you. Okay. So this is what we call a type of drawing. And I'm gonna try to help you visualize seeing an object in 3D. Okay. So follow along with me. Can everybody see the video?
Yes, sir.
Okay, what if I came to you and told you, okay, Mr. Thompson, I know you're a good TD teacher, but I want you to design me something on paper. I have this chair, this weird looking chair, and I want to make sure other people can draw it and make it wherever they are around the world. So I want you to create a projection for me. Write that for me. A projection, let me write it down here. A projection displays a drawing or measurements that is important to producing a constructed drawing. Okay, so if I say make me a projection, Mr. Thompson, I want you to create now something that others can read and they can make that chair that I want you to make for me. Does that make sense?
Yes, sir.
Okay, so I'm gonna give you some visuals as it relates to how I turn a chair into readable blueprint, so to speak. If any of you guys fathers are architects, you always hear him say or her say blueprints, right? This is where the idea comes from. Taking 3D shapes and putting it on a 2D plan. Okay, here we go. Let me zoom in. There we go. Okay, let me just close this out. Okay, so what the person is doing now is sketching it out, right? What did I say this extended ruler down here is called? Anybody remember this? The name of this ruler right down here? What is the name?
A T something, T square.
Square.
T squared. There we go. Who said that? I think that was Cameron, right? That's Cameron. Good job. So that's a T squared.
What did I say?
Oh, you answered the question, right? Because I asked what is the name of this ruler right here? You said T square, right?
No, that was Isaac or someone, sir.
That was Isaac. Okay, thanks. Isaac. That was a test and you passed. It's a double brain. So you were honest, right? That was a test as well. You're honest. I know you might not think that was actually a test, but trust me, I wanted to see how honest some people were, and Cameron passed. But look at this for me now. So that is a T square. Okay. Now, what is this blue triangle called? I'm not even gonna tell you what type of shape it is.
A set square.
Set square. Excellent. Okay. This is just a normal number 2 pencil. Okay. So we have T squares and set squares. T square and set square. You might be saying, well, sir, why do I need to know about these to draw 3D shapes? Well, the reason is that the T-square allows you to move along the entire paper without ever shifting your angle, right? Because if I'm drawing you a shape, you don't want to be distorted. You don't want to be like hard to understand. So you want everything to be in one angle, right? So the T-square allows you to move vertically, horizontally, without ever changing your angle. So you always have it across your paper, right? But before you do that, I want you to write this down for me. Next time your mother is going to the shop, ask her to buy baby powder. Can anybody think why I'm asking you to buy baby powder? Think about it. The T-square is gonna be rubbing against your paper the entire time. You don't want it to tear. So you want something to make sure that it flows and it also doesn't dirty up your paper. The baby powder is the best solution for that, okay? So before you start to draw now, you sprinkle baby powder on your paper and sprinkle it on the back of your T-square, and then bam, you can move anywhere without ever tearing your paper, okay? Sounds good, everybody?
Yes, sir.
Right? But remember, you are allowed to tape down, because if you look at the top right, you do see that this paper is taped down right here. So always tape down your paper on the four corners. So that also helps in not tearing your paper. So baby powder and taping your paper on the four corners. All right, we've done enough talking and setting up. Let's actually get into drawing. So look at this for me now. Right? I'm gonna ask you one question, right? When you look on this shape above here, right? There are three views, but just for argument's sake, the first view right here is gonna be called the front, because that's what you're gonna be looking on first, right? So if you were standing here, guys,